Today we're going to discuss the chemistry behind aldehydes and ketones. So, first let's talk a little bit about the things that aldehydes and ketones have in common. They are both carbonyl compounds, and if you recall, a carbonyl is just a carbon that is doubly bonded to an oxygen. The major difference between aldehydes and ketones is that with aldehydes, the carbonyl carbon is attached to just a single R group, whereby ketones have a carbonyl compound attached to two possible R groups, and those R groups may be identical or they may be different. Now, depending on the number of carbons involved, aldehydes and ketones may be considered structural or constitutional isomers of each other. So let's talk a little bit about nomenclature, and we're going to start with aldehydes. So here I have 4 examples of aldehydes. There's the carbonyl carbon on the end. And if we were to compare an aldehyde to just a simple alkane, you notice with my first example, I have just a single carbon. If this were an alkane, obviously it would be called methane. In the case of an aldehyde, we're going to drop that final E on methane and add the suffix al, al. So this is the common suffix to all aldehydes, al. Methane therefore becomes methanal. Now, my second example, you notice I have 2 carbons. If this were an alkane, it would be ethane. But again, keeping in mind that we have to impose that al suffix, ethane becomes ethanal. 3 carbons, propanal. 4 carbons, butanal. Now, you'll notice, hopefully, that we're still following the basic rules of nomenclature, where we look at the longest continuous chain of carbons. 1 carbon, 2 carbons, 3 carbons, 4. Hence the names methanal, ethanal, propanal, and butanal. Now, in your reading, you may have noticed that some aldehydes may go by other names, what we may call a common or trade name. And these are the names that you typically have to just commit to memory. If I look at some of the common trade names for my aldehydes, we've already said that a 1-carbon aldehyde could go by the name methanal, but it may also go by the name formaldehyde. 2 carbons, acetaldehyde. 3 carbons, propionaldehyde. 4 carbons, butyraldehyde. Now, I hope you've noticed that in the examples of aldehydes that we've seen, that the carbonyl carbon is always on the end of the chain. That is no coincidence. With aldehydes, the carbonyl carbon is always at either end of the chain, and it will always be designated as carbon 1. Now, we also tried making comparisons to just the standard basic alkane. And we know from past experience that depending on the length of carbons, the chain itself may branch out. This implies, therefore, that aldehydes are also prone to branching. Now, I have an example that I want you to think about. I would like you to try to draw and name all of the isomeric 5-carbon aldehydes. So name and draw isomeric 5-carbon aldehydes. So again, let me translate. You're looking at an aldehyde that has 5 carbons, and I want you to consider all of the possible structures and their corresponding names. Now, a 5-carbon aldehyde should have the formula C5H10O. We're going to come back and look at this again towards the end of the video. But for now, I would really like to go on and talk a little bit about ketones. Now, we said that the distinguishing characteristic of a ketone is a carbonyl carbon with an alkyl group on either side of it. Now, because of that, because you have those two alkyl groups on either side of the carbonyl, ketones by definition must be 3 carbons or more. Now, as with aldehydes, we are still going to be considering the longest continuous chain of carbons. I'm going to amend that just a little bit and say the longest continuous chain of carbons that bears the carbonyl carbon. Okay? So if you look at my first example, I have 3 carbons. The carbonyl carbon is right in the middle. So safe to say that the carbonyl carbon represents carbon 2. Now, 3 carbons in a continuous chain. If this were an alkane, it would be propane, yes? Well, as with the aldehydes, we're going to chop off that E, that final E from the alkane, and replace it with a suffix. In this case, the suffix is O-N-E, or own. So I've got 3 carbons. Propane, yes? Propane's the parent. But propane is going to become propanone. Now, I would imagine some of you may be wondering, okay, I've got the longest continuous chain of carbon stuff down. I got to also look for where the carbonyl carbon is within the chain. Does this mean I have to designate the positioning of the carbonyl? And the answer is yes, you do. Now, in some cases, it may be a bit redundant. So if you look at our 3-carbon ketone, which by the way is also known as acetone, since the carbonyl is in the middle at carbon 2. We could say 2-propanone. Now, the reason that this may be considered redundant is that with 3 carbons, and considering the carbonyl carbon always has to be inside the chain and not at the ends, the number 2 carbon is the only place that could also be identified as the carbonyl. So it is a little redundant. So I'll put it this way to any of my students that may be listening. On a quiz or exam, if you were to drop the 2 and just say propanone, would I be okay with that? And the answer is yes. Now, let's go to a ketone with more carbons. So here I've got 4 carbons. The carbonyl is at carbon 2, obviously. So this would be 2-butanone. 2-butanone. So again, just keep in mind the longest continuous chain of carbons and where the carbonyl carbon fits in. Now, if you've done a little bit of reading, you may know already that there's more than one way to name a ketone. And I'm going to use 2-butanone as my example. So here's the 2-butanone. Now, if I'm looking at this compound, obviously the most striking feature in 2-butanone is the carbonyl carbon. But if you notice, there's an alkyl. There's a distinct alkyl on either side of the carbonyl. On the right side, your right, of the carbonyl, this clearly is an ethyl group. And then on your left, that's a methyl. So you also have the option of using what I call the alkyl method in naming ketones, where you just name the 2 alkyl groups on either side of the carbonyl. But remember, you gotta name them alphabetically. So ethyl obviously comes before methyl. So ethyl, methyl, and then the word ketone. Simple enough? All right. A couple minutes ago, I asked you to think about the possible numbers and names of all the isomers for a 5-carbon aldehyde. So here's what I came up with. Compare this to what you came up with, and let's see what we got. So obviously, I could place all 5 of my carbons in one continuous chain and call this pentanal. Now, I got to consider how the carbons may branch. So, the next example, you notice that instead of having all 5 carbons in a continuous chain, I've got 4 carbons. And the 5th carbon is represented as a branch. So, a 4-carbon aldehyde would be butanal. But it's butanal with an obvious methyl group. So it's methyl butanal. Now remember what we said earlier, that for aldehydes, the carbonyl carbon is always carbon 1, which means in this case, carbon 1, carbon 2, carbon 3. So we are looking at a 3-methyl butanal. Now, if you look at the second example, it looks a lot like, I'm sorry, if you look at the third example, this is the third example right here. It looks a lot like the second example. The only difference is the positioning of the methyl group. So, if this is carbon 3, this must be carbon 2. So, we have a 2-methyl butanal. All right, last one. You notice now I have an aldehyde in which 3 carbons are in the longest continuous chain, and the 4th and 5th carbon are represented as branches coming off the middle carbon, or carbon 2. So a 3-carbon aldehyde, we said, would be propanal. But you notice I have a methyl coming off carbon 2, and I have another methyl coming off carbon 2. Hence the name 2,2-dimethyl propanal. Okay, guys, so keep in mind always that with the nomenclature of both aldehydes and ketones, you got to take into consideration the longest continuous chain of carbons. You also have to note where the carbonyl carbon is. In the case of aldehydes, the carbonyl carbon will always be on either end. Doesn't matter which end, it just has to be on the end. In the case of ketones, the carbonyl carbon has to be somewhere within the chain. All right, guys, thank you for your attention. On our next video, we're going to be discussing synthesis of both aldehydes and ketones.